Hello everyone, welcome to my channel. Hope you're all doing well. Last week, we covered the different types of joins in SQL. Continuing from the SQL series, today we will cover a simple topic around store procedures. So before we do that, let me show you the answers for the last week's exercises. So before I start the examples, I'd just like to quickly ask you all to subscribe and like this video if you like it. Obviously subscribe if you don't want to miss out any future videos, and also hit the bell icon to get notified each time I upload new videos. All right, let's proceed. So if you remember from last week, we've looked at a couple of tables, or we've used a couple of tables to actually understand joins. So one of them was the stock items, which is nothing but all the stock within the company. And the second table is the orders, which is nothing but all the orders placed within the company by the customers. Yes. So if you look at the first one, which is nothing but write a query to find data that exists in table A, but does not have a corresponding entry in table B. So if you consider table A as stock items and table B as orders, so what we're trying to find is any stock that hasn't been purchased by any customer. So to do that, what I'm doing is, I'm doing a left join. So why I'm doing a left join? As you know, left join will bring up everything from the left table, in this case, the stock items table, but only the matching entries from the right table. So obviously, if there is no any matching entry, it'll output the right table column value as null. So you've seen that in the last week's video. So in this case, I'm only saying, I don't want anything that actually matches. I just want entries that don't have a corresponding entry in table B. So in this case, what I'm saying is, actually, give me all the stock items that doesn't have a order placed yet. So in this case, because we know that the right table, the return value will be null, I can basically say, where order ID is null, and therefore, it'll only return anything that doesn't actually exist in orders table. So there you go. That is the answer for the exercise 1. Now, exercise 2 is just the opposite. So I'm saying is, write a query to find data that does not exist in table A, but has a corresponding entry in table B. Now, I've cheated here a little and basically reversed the table. So I'm basically saying, my left table now is orders and the right table is stock items. So I'm doing a right order join. And as you remember from the last week's video, right join obviously returns everything from the right table, but only the matching entries from the left table. So in this case, if I do the same thing here in the where condition, where I'm saying on the left table, which is the orders, the order ID is null, this should basically give me the identical result. So there you go. Those are the answers. Thank you. All right, let's now move on to today's topic. So we're going to cover stored procedures, and we'll look at some of the examples as well. All right, so what is a stored procedure? Simplistically, they encapsulate the data access logic into a single place. So you can write multiple queries in a single stored procedure. What you can also do is you can pass inputs into it. So your application can pass values that are entered on the screen, for example. So for example, if I'm searching for a customer within an application, I either give some sort of customer ID, or I might be giving the actual name of the customer, or if the customer has any orders, I might actually say, can you give me the order information for this customer? So these are all the inputs that I'm actually giving into the software to search something. So there are obviously different ways of implementing how do you query the database. Assuming it's a relational database, there are different ways. So one of the ways, or one of the widely used ways at the moment, is stored procedures. That's primarily because of the following benefits. So one of them is performance. So stored procedures can be optimized. What does that mean though? So stored procedures create something called a query plan. Um, and this is automatically created by the database management system. However, using the query plan, you can actually optimize the queries or statements within the stored procedure. And once a stored procedure query plan is created, as long as the stats on the tables are up to date, um, most likely your stored procedure will use the same query plan always, and therefore you can be confident that okay, you've it's performing very well. So the second benefit is you can actually give execute access to the stored procedures. Um, this means that you don't have to give users access directly to the tables. So if someone actually goes into the database of a live production system and basically tries to access the tables themselves, they won't be able to access any of them because they don't have actually access to do or write, either read or write. So this is especially useful in cases such as preventing SQL injection. All right. So the other benefit is you actually cause reduction in network traffic if using stored procedures. Um, I know that is a broad statement, but the reason for that is obviously when you're writing direct queries into your application without using stored procedures, and if you have 2 or 3 different queries to run, obviously you'd be writing separate database calls for each of those queries. However, when you have a stored procedure, you can basically put all those select queries into one stored procedure, for example, or 2, depending on your application's logic, and you'd basically call or make less number of database calls. So obviously, you're reducing the network traffic there. There is one disadvantage of using stored procedures, though. So because each table has different mechanisms, like you're actually querying the database, or you're actually inserting data into it, or you're actually updating data into it, or you're deleting data from it. So generally, if you have a single table, normally, depending on the application logic, you might have to write 4 different SPs for handling these 4 different transactions: insert, update, delete, and select. Sometimes you might actually put insert or update into the same stored procedure, depending on certain logic. All right, so let's now look at a few examples of how do you create a stored procedure or alter it. So for the examples, I've created 2 files. One is SP templates and the other one is SP example. SP template is nothing but a template to create a stored procedure, and the SP example is one SP that is created using this template. So how do you create a stored procedure? So to create one, you'd need to write create procedure and then the name of the stored procedure. And then you specify what parameters or inputs you need to pass into the stored procedure. These are optional, so you don't have to pass parameters if you don't have to. And if you do, basically, this is how you do it. So you need to give a parameter name. So they actually usually start with @ symbol and the name of the parameter. And then you specify what data type it is. And if you have a default value, so if you have this parameter, which doesn't have to be always passed by your application, you can specify a default value if it's not passed. And if you have multiples, you can actually list them by adding a comma between each of them. So, and after that, you have as begin, and then that's when your body starts. And you can also have your change history, which normally includes your author, creation date, and the description of what the stored procedure is trying to do, and the change history, so which normally would be very useful when you're trying to investigate something on this stored procedure in future. And as a rule of thumb, it's probably always beneficial to have a set no count on. This is primarily to prevent extra result sets from interfering with the selected statements. And after that, this is where you start writing your queries. So obviously, as I said earlier, so you can have multiple queries within your stored procedure. You don't necessarily only have to have select. You can also have insert statements. You can have update statements. You can also have delete statements. So obviously, it's up to you what the stored procedure is doing. And after that, you basically end by writing end. That's it, basically. So that's your stored procedure. Go is nothing but it's just a commit, basically. So it doesn't normally have to be there. All right, so using that template, I've created a stored procedure. So the function of this stored procedure is I'll pass in a customer ID, and it basically will return all the orders placed for that customer ID. Obviously, when I run that, the stored procedure doesn't exist. That's why it is erroring out. So let's try and create it. Or actually, before creating, let's look at what I did here. So as I said earlier, create procedure. I'm using the schema name as dbo. This is my name of the stored procedure. Obviously, I've structured in a way that, okay, if I look at the name of the stored procedure, I can recognize what the stored procedure is doing. So my parameter is customer ID, which is a big int, as begin, and my change history is here. Obviously, as I said, set no count on, and this is where my select query starts. So what I'm doing is I'm obviously selecting from the customer, joining to the order, joining to the stock. I'm getting the order ID, order date, total price, quantity, stock name, and the per item price. Obviously, in the where condition, I'm saying, okay, only get me orders related to the customer ID that matches the customer ID that's passed in. Now, obviously, I've not created it now, so let's try and create that. Now, if I execute this, obviously, this will return me the orders related to that customer ID. All right, so that's all well and good. However, in future, if you do want to modify this, what would you do? So the way you do it is basically instead of create, you write alter. That's it, basically. So that that modifies the stored procedure. Obviously, in this case, I've not modified anything, but I can run that. But before running that, I just want to show that I need to create a change history. So this is more, it's up to you, but I find it very useful. So I can say, John modified it again on the 10th of November, 2018 or 2019. And I can say added stock ID. So in here, I can say I have I need stock item ID as well. All right. So if I alter it, there you go. It says, completed successfully. Now, if I select it, I can see the stock item ID. So as you can see, it's not that difficult.